Hello, good morning everyone. Today we will see how to calculate sample size for a prevalence study using proportion. Sample size calculation can be done in different ways. Two ways are one using online calculators. There are so many online sample size calculators available. One example I am giving is openepi.com. Another method is using a formula. When you are calculating sample size based on prevalence of a problem, okay, we need two values mainly. One is the anticipated prevalence or anticipated frequency of the problem that is obtained from previous research, and precision also is required. Precision is the difference between anticipated prevalence or expected prevalence or frequency of the condition and the least accepted prevalence. It is otherwise known as acceptable variation in the prevalence. Now we can go through the sample size calculation formula for a prevalence study. It can be done using OpenAPI also, using the option for sample size calculation for proportion. Okay, now I will tell the formula. Sample size is equal to Z alpha multiplied by Z alpha multiplied by P multiplied by 1 minus P divided by precision squared. P is the expected prevalence of the condition under study. It is obtained from previous research. Precision, as already discussed, is the difference between prevalence and the least accepted prevalence. How much variation in prevalence is acceptable for our study. It is otherwise known as allowable error in the expected prevalence. It can vary from 5 to 10 or 5% to 10%. We can take absolute numbers 5% to 10%, any number based on the previous research. Then it is known as absolute precision. We are taking the absolute number 5 or 10 or any number between that. Above 10 is not acceptable. Okay. Most of the time we go for 5% allowable error. If prevalence is low, sometimes conditions are like that. Prevalence or condition is very low, less than 5%, maybe 1% or 2%. Then we cannot take allowable error or precision as 5% or 10%, right? So then precision can be calculated as 5 to 10% of the prevalence in that situation. Then it is known as relative precision. Z value is the standard normal variate. Okay. Z value for two-sided distribution with a 95% confidence interval for an alpha error. Okay, Z value for alpha error, that only is known as Z alpha. That value is a constant, that is 1.96. That can be used when you are using this formula. Okay, these are the different Z alpha values for alpha error. When alpha error is 0.1, that means it is for 90% confidence interval. Z alpha value is 1.645. When alpha error is 0.05, that means for 95% confidence interval, Z alpha value is 1.96. When alpha error is 0.01, that means for 99% confidence interval, Z alpha value is 2.575. Okay, now we can go through some examples. First example is like that. Please go through it. One researcher wants to study the prevalence of diabetes among adult population in a district in Malaysia. Okay, it's a prevalence study, right? Usually, cross-sectional studies are used for calculating or estimating prevalence or proportion. Okay, so it is a cross-sectional research. From previous research, the prevalence of diabetes among adults in Malaysia is 30%. Okay, so P is 30%. Calculate the sample size for a precision of 5% for a confidence interval of 95%. Z alpha value for 95% confidence interval is 1.96. Now we can apply these values in the sample size formula. Z alpha squared multiplied by P is the prevalence of the condition, multiplied by 1 minus P, that's the prevalence of not having the condition or proportion of not having the disease, divided by precision squared. So here Z alpha value is 1.96, prevalence is 30%. So we have to convert it into 30 divided by 100, that will be 0.3. 1 minus P is 1 minus 0.3, that will be 0.7. Precision is 5%, so it will be converted as percentage. 5 divided by 100, 0.05. Okay, so when you add all these value and substitute in the formula, 323 is the sample size. Okay, hope it is clear for you. One researcher wants to study the prevalence of anemia among women in a state in Malaysia. Okay, so this situation we are studying, the researcher is studying the prevalence of anemia. From previous research, the prevalence of anemia among women in Malaysia is 40%. So P is 40%, right? Calculate the sample size for a precision of 5% for a confidence interval of 95%. So Z alpha value for 95% confidence interval is given as 1.96. So sample size is equal to Z alpha squared multiplied by P multiplied by 1 minus P divided by precision squared. Okay, here also we are substituting the values. 1.96 the whole squared multiplied by 0.4, that is 40%, right? 40 divided by 100, so it is 0.4, multiplied by 1 minus 0.4, that is 0.6. That's a proportion of individual, proportion of women not having anemia, divided by precision. Precision is 5%, so we have to convert it into 5 divided by 100, 0.05. So we can calculate the sample size as 368.79, which will be rounded as 369. Okay, next situation is sometimes the population from which you are collecting the sample will be smaller or finite population. In that case, we need to add a correction value. Okay, for example, if total number of students in a college is only 600, so you have to calculate the sample size based on the formula first, then you have to use this correction for finite population to get the exact sample size required. So correction formula is like that. N is a corrected sample size is equal to N0. N0 is the sample size calculated by formula divided by, you have to take 1 plus N0 minus 1 divided by capital N. Here capital N is the size of the finite population. Okay, now we can see one example, then it will be very clear for you. Okay, for example, if total number of students in a college is 600 and the sample size calculated based on the formula is 384. So we can apply this correction formula because it's a finite population or sample size should be corrected based on the finite population because population is small. This correction can be used to calculate the sample size for finite population. I told you corrected sample size will be calculated sample size divided by 1 plus calculated sample size minus 1 divided by total finite population. Okay. So it will be 384, that is a calculated sample size, divided by 1 plus 384 minus 1 divided by 600. Here 600 is a uh, uh, population, that is a finite population size, or that is a size of the sampling frame. Okay. So 384 divided by 1 plus 383 divided by 600. So we can get the value 384 divided by 1.64. So corrected sample size will be 234.15. So you can round it as 234. So calculated sample size was 384, but when you corrected it became 234. Thank you.